my name is NURUL NADIAH BINTI ZULKEFLEE and my matrix number is 197729. So for today, I would like to talk about one of the application of the complex function, which is the Cauchy Riemann. So have you guys ever wondered how aeroplane could fly high up to the sky with there are many forces acting on them? So there are four forces that are acting on the airplane. The first one is the weight, thrust, lift, and drag. So we can assume that there is a potential flow that flow through this airplane, which is we can assume that as velocity potential equals to U, and also stream function equals to V. This velocity potential is also known as potential flow, which is an incompressible steady fluid flow. U is the velocity potential, meaning we imagine that there's a flow of fluid in the plane such that velocity vector of fluid at each point gradient of U. This is the equation. So by differentiating the Cauchy Riemann equation for the second time, we can get this equation, which is U is the harmonic function and it is divergent. Fluid is incompressible, as I said just now. So V satisfies the Laplace equation by similar analysis. Also, Cauchy Riemann equation can imply the dot product, which is this U and V is a constant curve. It's the same. Therefore, we can get this Cauchy Riemann equation that we learned in engineering maths 3. Thus, it fulfills all of this Cauchy Riemann equation. So this is the important features of Cauchy Riemann equation. That is it from me. Thank you.
Hi and Assalamualaikum. My name is NURUL SUHAILA binti SAZIHAN. My matric number is 196142. So today I am going to present about vector calculus. An application of vector calculus in our daily life is a plane flying in a crosswind. As what I will show previously, a plane is flying with the opposite direction of the crosswind. So here I am going to show the calculation of the formula for the vector of the vector calculus on the plane. Okay, based on the sketch below, it shows that the vector have a direction x and y. So here is the velocity of the plane and this is the wind that cross the plane. Okay, so to get the r, it's velocity of the plane plus velocity of the wind. Okay, so since the vector have a direction, they have an x and y. For example, VPS equal to 0, refer from here, and VPY 300, VWX, since there's an angle of theta equal to 45, so VW equal cos 45, VWY equal to VWX sin 45. Since we want to find the r, which is the vector of it, so it will be VP plus the vector of VP plus VW. So it will be VPX, VPY, VWX, and VWY. As the direction, they will also have the theta, which is tan -1 ry equal over rx, and the magnitude is square root rx square plus riy. So that's all about the vector calculus. Thank you.
Hi, my name is NURUL binti AZIZ. My matric number is 198285. So now I'm going to show you an application of Fourier series. So I think we just straight to the point. Let's go! So before we go to the application, let me tell you briefly what is Fourier series. Do you know what is Fourier series? Okay, Fourier series is an expansion of periodic function in terms of sum, cosine, and sine. So let's check it out. What is the application? So let's go. So here in my hand, I have a recorder which is I'm using my smartphone so that I can show you how Fourier series looks like. Okay. So when we click the red button, when we say something near the speaker, we can see the sound wave are produced here. If you can see, it is a line. I mean, just only a wave, but a different amplitude and frequency. This happened because of this wave produced from combination of cosine and sine wave, which have different amplitude and frequency. So the combination will we will get that kind of shape. When I say something louder, something loud, the wave become the amplitude become higher. If I say something slow, the amplitude become lower. See, you can apply the Fourier series in recorder. So yeah, that's all for me. Thank you.
And good afternoon. Today, my name is FATINAH with HAFIZ. Today, I want to talk about Fourier transform. In our life, Fourier transform is application of. There are many applications of Fourier transform, such as a filtering of a picture. So, I would like to show you how to filter the picture. This is how the application. This will filter the picture. So for this filter, we can do a Fourier transform, which is we use the equation. Then the equation for Fourier transform is this. This is predicted signal. Then we have to integrate. The equation is to change time domain signal into a frequency domain signal. The difference between Fourier series and Fourier transform is it is non-predicted signal. That's all for me.